Hello viewers, in this video we are going to learn about instruction codes in basic computer organization and design. Instruction code is a group of bits that instructs the computer to perform a specific operation. Okay, usually instruction code consists of two parts. First part consists of operation code which is also known as opcode. Okay, in second part address is stored. Okay, here you can look at the example instruction format given here. This instruction code consists of two parts, where first part consists of opcode and the second part consists of address. Okay, whereas coming to the opcode, it defines the operations to be performed. Examples for operations are add, subtract, multiply, complement, shift. These are all some examples for operation code. Okay, coming to the size of the opcode, a n bit opcode is required to perform 2 power n distinct operations. Okay. Let us discuss about the address part of the instruction code. Okay. Address part of the instruction code, it specifies the register or memory word from where the operands to be found in order to perform the operation that is specified in the opcode part of the instruction code. And also after performing the operation where the result is to be stored either in register or memory word where the result is to be stored, that is specified in the address part of the instruction code. Okay, address part of the instruction code, it specifies the register or memory word from where the operands are to be found or the result is to be stored. Okay, coming to the size of the address, a n bit address is required to store 2 power n memory words. Okay. Let us now discuss stored program organization. Okay. The concept of storing instructions and operands together in different portions of the same memory is known as the stored program organization concept. Okay. Here in this example, you can observe here in the first portion of the memory, instructions are stored, and in the second portion of the memory, operands are stored. And a collection of instructions are also known as program, and operands are also known as data. Okay. And here, in addition to memory, here processor register also specified. In a basic computer organization, computer contains only one processor register. Usually, whenever the computer is designed with single processor register, that register is known as accumulator. Okay, what is the use of accumulator? So, whenever ALU operation is performed, one of the operand is always taken from the accumulator only. Okay, and after performing the operation, the result also is going to be stored into the accumulator only. Okay, so this is a very important point about accumulator. Once again, I repeat, whenever ALU operation is performed, one of the operand is always taken from the accumulator, and after performing the operation also, the result is going to be stored back into the accumulator only. Okay, since one of the operand is always taken from the accumulator, there is no need to store that operand explicitly into the memory. Okay. Let us now discuss the format of instructions stored in the memory. Okay, if you take any one of the instruction that is stored in the memory, it takes its format. Okay, students, this is the format we have discussed in the previous slide. Okay, very similar to that. Here also, this instruction it takes two parts. First part contains opcode, and the second part contains address part. And here the size of the opcode, it has 4 bits. Okay, a 4-bit opcode, it can specify 2 power 4 number of operations, 2 power 4 number of distinct operations. What is 2 power 4? 64. So, a 4-bit opcode can specify 64 number of distinct operations. Okay. Whereas coming to the address part of the instruction, here in this instruction, address part takes 12 bits. Okay, a 12-bit address part, it specifies address for 2 power 12 number of memory words. What is 2 power 12? 4096. So, with 12 bits of address field, address for 4096 memory words can be created. Okay, here students, both the instructions and operands are treated as memory words. Okay, here you can notice every memory word, either it is instruction or operand, it is of size 16. Okay, and this memory capacity is 4096. That is, inside this memory, 4096 memory words. That may be either instruction or operand. So totally 4096 memory words can be stored. So to represent memory address for these memory words, 12-bit address field is required. Okay. Uh, if suppose if we take any one of the operand stored in the memory, uh, it takes this format. Okay. So you can observe here both the instruction as well as operand, both are in same size, that is both are having the 16-bit size. Okay. Here all the 16 bits are completely used for storing the operand. Okay. Students, coming to this instruction code, the first part specifies the opcode, right? So what opcode specifies? Opcode specifies what is the operation to be performed. Okay, to perform any operation, an operand is required, right? So from where the operand can be found, that is specified in the address. Okay, so in three forms, address for the operand can be specified. So what are the three forms? Using immediate addressing mode, direct addressing mode, indirect addressing mode, address for the operand can be specified. Whenever immediate addressing mode is used, uh, the operand itself is explicitly stored in the address field of the instruction. And if direct addressing mode is used, then the address of the operand is stored in the address field of the instruction code. Okay? And if indirect addressing mode is used, then address of the memory word that holds the operand is stored in the address part of the instruction code. Now we are going to discuss if direct addressing and indirect addressing is used in the address field of the instruction code, how control unit find the operand required to perform the operation specified in the opcode of the instruction with suitable examples. Okay. In this example, instruction code takes this format. This instruction format is very similar to the one what we discussed just now. But here additionally one I bit is added. Okay, I stands for index bit. It is called as addressing mode field. Okay, if address mode bit is set to 0, it indicates that direct address of the operand is stored in the address field of the instruction code. Okay, if suppose I is set to 1, then the address field of the instruction code contains indirect address of the operand. Indirect address of the operand. Okay, let us now discuss if direct address is specified in the address field of the instruction, how the operand is found. Okay. So here, just look at this memory. Here, all the instructions are stored in the first portion of the memory and all the operands are stored in the second portion of the memory because it follows the stored program organization. Okay, if we take one of the instruction that is stored in the memory address 22, it takes 0 in the I bit field and add in the opcode and 457 in the address part of the instruction. Okay, since it contains 0 in the mode field, it indicates that direct address of the operand is stored in the address field of the instruction. So, if the control unit goes to this address, it can find out the operand that is required to perform the addition operation. So, that operand is now it can be fetched from 457 memory address And from where the another operand can be found? Obviously, one of the operand required to perform the ALU operation is always taken from the accumulator. Okay, so now to perform addition operation, we got both the operands. Then addition operation is now performed by the ALU unit. So this plus symbol indicates the addition operation. Okay, so after performing the addition operation, the result is going back to be stored into the accumulator only. Okay, if suppose address field of the instruction contains the indirect address, how the operand is found? Let us now discuss. Okay, in 35th memory location of the memory, the instruction contains 1 in the mode bit field and add in the opcode and 300 in the address part of the instruction code. Since 1 is stored in the I bit field, it indicates that uh, indirect address is stored in the address part of the instruction. Okay, so to find out the address of the operand, the control unit goes to this address and it can find the effective address of the operand from this location. Okay, so when it goes to that memory location, it can find out the operand. Now, now this operand can be fetched from this memory location and the another operand is taken from the accumulator. Since now both operands are available, the addition operation can be carried out by the ALU unit, and after performing the addition operation, the result can be stored back into the accumulator. Okay, this is how operands are found whenever the direct and indirect addresses are stored in the address part of the instruction code. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.